All right, so now we're going to look a little bit at dot diagrams. Dot diagrams are used to represent our number of valence electrons that we have. We use these when we are looking at how something is giving, taking, or sharing electrons in bonds when we're looking at how chemistry is happening. So they consist of the symbol of the element, which represents the kernel or core of the atom. And dots, which represent the valence electrons. Kernel is the nucleus of the atom, and all of the electrons except valence electrons. So here are our steps. First, we are going to write the symbol of the element. And then we are going to put a pair of electrons at the 3 o'clock position first. So our symbol here, for example, is going to be X. And then I would put a pair of electrons at the 3 o'clock, 3, 6, 9, 12 position, unless there's only one electron and then there's only one dot. Then I put a single dot on the other sides of the symbol. I'm going to start pairing if necessary. I cannot exceed 8 dots. This is going to feel really similar to your electron orbital, your electron configuration graphics in the boxes. So I've already written out my electron configurations here to save some time. So for magnesium, my atomic number is 12. So I have 12 electrons I'm dealing with. The only ones I'm worried about are my valence electrons, which are the ones in my outmost energy level, which are going to be my 2 valence electrons in that 3 level. I would draw my symbol, Mg for magnesium. I have 2 valence electrons. They're going to hang out on the side right here. You might also see it written like this. That's okay too. This shows us that there are 2 elements in the S sublevel together, right? So it's a little bit more accurate as to where the electrons are actually hanging out. But this one is more accurate for the kind of chemistry that magnesium could do. So we're going to stick with this one. You will also see them drawn like this. This is more accurate to what's actually happening with the electrons. This one's more accurate to what chemistry it could do. So for phosphorus, we have 15 is our atomic number. We have 15 electrons, right? But we are only looking at our 5 valence electrons. So I put down P for phosphorus. I start with my 2 here at the 3 o'clock position, and then I have 3 more I need to put in. 1, 2, 3. For fluorine, I am only looking at my valence electrons. I have 7 valence electrons in the 2 level. So for fluorine, I'm going to put my symbol for fluorine. I'm going to put my 2 electrons, my 2 dots here, and then I'm going to start filling in. So 1, 2, 3, 4, 5. Now that I have 1 in each side, now I can go back in and add a second one. 6, 7. So that would be my electron dot structure for fluorine. Argon. I'm only looking at my valence electrons. My valence electrons in this one are in my 3rd level, my 3rd primary energy level. So I would have 8 valence electrons. If I have 8 valence electrons, I know that they're all paired because I have 8 or a total amount of valence electrons that I can have. I'm just going to do the process so you can see it one more time. I have 2 electrons on the side. 3, 4, 5, 6, 7, 8. Okay, and finally potassium. We are looking only at the valence electrons. There's only 1 valence electrons in potassium. It's in that 4 level. So I'm going to put K, my symbol for potassium, and give it its 1 lone electron. And there is my dot structure for potassium. Electron dot structures are useful in showing how electrons might move when we're doing bonding, like I said, so we will see these coming up again later.